Right, welcome to part 3. In part 2 I showed the way I located the position for drilling the regulator body by putting a transfer punch through here to make the location. Now then, come to fit the actual rod, it don't go in. And what I've noticed is, bear in mind I haven't got any screws for this flange of the right size, and what I should have done is put some bolts in there, or some screws in there to really hold that, but I thought there was enough meat on there, on this bush, to give a decent location, but evidently not. And as you see, so you can see that there's a slight bit of wobble there, and that's enough to stop this shaft located in the hole that we drilled and reamed last time. So what I'm going to do is take the throttle body out and plug the hole that exists now, fettle it all back to a single block and redo the thing. Yep. Right, in order to make this bushing more secure, I've had to make some screws. The shops are shut at the minute, so needs must. Anyway, they've turned out alright. So, second time round, we'll give it a tap and see where we're at. Hello again. Since the last video, I had some real fun and games with this job. Right then, let's just start at the beginning. On the last video, we'd drilled and reamed this feature here, and to the drawing it should have been a 5/16 hole. This is actually 3/16. Had it been 5/16, you can see it would have broken out of this wall here, which is unacceptable. The reason being, if you look at the original design drawing, I've just done a sketch here to simplify it. The way this works is you've got your 5/16 hole coming through the block there. Within that you've got this bush here, which is silver soldered at this point here to this shaft, which actuates the lever, which actuates the valve. So this whole thing then is retained. There's a groove in the bush and a pin there. So this whole thing is free to rotate. It's also retained from falling out into the boiler. What we've got here is a step in the shaft, both on this side and on the main shaft, which goes to the outside of the boiler. So when you need to maintain the regulator, this shaft can be removed and the whole thing can then be lifted out of the top of the boiler here. Now then, because mine won't allow for that because of the position of this hole relative to this wall, I've had to think of something else. And before explaining that, when I came to fit this in the boiler and put the shaft through to line up with this hole, it wouldn't go in. Not at all, not even try to go in. So I thought, well, I've buggered it up, I've put the hole in the wrong position. So I soldered this up, plugged it and soldered it, and redid the whole thing again with the transfer punch, making sure that everything was bolted on these flanges and at the top here, so everything was solid, and punched it again. And when I took the thing out, I thought, well, it doesn't look much difference to the last one. Anyway, so I drilled it, reamed it again, and tried the whole assembly again, and it didn't go in. So what's going on here? Anyway, what it turned out to be, after a lot of buggering about and measuring and what have you, what we've got here with this bush is in effect a silver soldered joint in the side of the boiler. And this design of regulator positions this hole in such a place that any misalignment or out of position of this bush is going to affect the position of it, and also any out of square. If you can imagine this flange being slightly cockled, it only needs to be a few thou, in my case that's the case. Then you imagine a shaft coming down here, it hits that point there, the position on that face is correct, but it's not going to want to go through that hole because these holes have been made square to the block itself and the retaining cap, etc. So you've got one squareness there, a different squareness here, and you get a conflict. So right, to get around this situation, what I've had to do is redesign how this thing works. Now then, I've made a actuating arm there. Now if you can imagine, that's going to sit in there. Well, you don't have to imagine, you can just see it. Look. And the operating shaft will come through. Now I've made this square because it's the only thing, given the amount of meat I've got here, that will work and actually give us some purchase on this lever. But what I've had to do, well, if you can imagine, there's nothing retaining this lever, so if this shaft is removed, then that can fall straight into the boiler. So I've had to make some sort of retainer for this. So as you can see there, I've made a groove and a retaining plate. So the way this works is that retaining plate will be bolted in there, and it will retain that lever there. So when the shaft's removed, this ain't going to fall out into the boiler. Right, so I'll assemble it all together, and you'll see how this works. But I've not shown too much of the machining on this. It's, you know, I've not been in the best of moods with it, to be honest. It's been a real ball ache, but I think it's there now. So I'll put the thing together, and then we'll stick it in the boiler and just make sure everything lines up and works. Yes, something, just going back to the alignment problems, not just this way, or vertically or horizontally if you like, but when I came to fit it, one of the positions, it's hard to but it was slightly cockled like this. What I did is I put the shaft through and left all this loose, and you could see that the top here was not square to the top of the boiler. So what I've had to do is I've just taken a little bit out the top of this retaining cap. As you can see, that side is a little bit deeper than this side. So when that's bolted on there, it makes everything true to the shaft coming in from the side. Anyway, all a bit complicated. Let's put the thing together and see what it looks like at the end. So there you see the action of the valve. Something extra to the drawing, I put a stainless steel pin here as a stop, because there is a chance that this can overrun if the stop isn't there, and you have a chance of the valve plate falling into the boiler. Also, when I made the square hole in this lever, I was set up on the mill, and I wish I'd got some footage of it. I may have some somewhere. I'll have to have a look. But set up on the mill and the rotary table to cut these flats, and while I was at it, I made a little brooch out of some silver steel, softened it up and cut it, and just put some little steps on there, and didn't bother re-hardening it, and just drill the hole of the right diameter cross flats, and then just push this through in the vise, and it gave a beautiful square hole. So yeah, worth a try is that. This is the steam pipe. The reason it's got two sides of the pipe is the wet header flange on the boiler is 5/8, but the hole required for the steam pipe in the regulator is 1/2 inch. You can see there's a little O-ring in there. So luckily 1/2 inch pipe slides into a 5/8 copper pipe bore perfectly, and so I just silver soldered that in. Right, we can put it together on the Loco now. Just see how that fits. There we go. Nice and tight. Just hope it's steam tight. And that's it. Just need to put some the bolts on here, which provide the seal. There's an O-ring in between these two plates, and you can hear the valve opening and closing in there. So after a lot of buggeration, it's finally working. But the moral of this story, or what I've learnt from this, the design of this regulator block doesn't leave much wriggle room, if you like, and the hole for this actuation shaft in the block is so close to the edge, and of course you're governed by the diameter of the hole that this goes in, and as you saw previously, it is pretty much the same diameter, less a few thou to allow the thing to go in. So basically this design is reliant upon how accurately this joint has been silver soldered, and you know, just a few thou out and the job's buggered. You've got to califudge it somehow. So anyway, hopefully it'll work. There won't be any problems. I do hear that this design of regulator can cause problems, leaking, etc. And some people do use ball valves, but I think we'll try this, see how it goes, and if we need to change the regulator in the future, then that'll be done. But I think it's only fair to give it a shot.